All right, so graphing quadratics review. Let's start by looking at just this first page. So the highlighted words, okay, we got quadratic function. That's the x squared function. So our x is now squared. Whenever you see the x squared, that's going to be a quadratic. And it says right here the graphs are U-shaped. So our absolute value ones were V-shaped. Our linear ones were a straight line. Now these are U-shaped. And the U-shaped ones actually have a special name. They're called a parabola. So we haven't seen a special name really before. A line was just a line, a V-shape was a V-shape, but now the U-shape can be called a parabola. All right, so down below here you can see the actual graph, and there's a few things that's labeled on here. You have a vertex, which is always our starting point. We're going to look at that first. Axis of symmetry goes straight down through the vertex, and that's always going to be like a mirror. So whatever is on the right side is the same as on the left side. It's a mirror image on both sides. So as we start to find points on one side, those points are going to be on the same points will be on the other side too of the axis of symmetry. Now that axis of symmetry will not always be on the y-axis. It'll be wherever your vertex is. So if your vertex moves left or right, your axis of symmetry is going to move left or right as well. So you're also seeing decreasing, increasing there. That's just kind of more like how the roller coaster is going. If you thought of this as maybe a roller coaster, you're coming down from left to right. So you're decreasing, but then as soon as you get to the vertex, you turn the corner and you start to increase. And you go up on the roller coaster. So we'll see more about that in Chapter 4, where the roller coaster have a lot more curves in it, because we're going to see more curves in Chapter 4. This one, just one curve only on this one. All right, let's take a look at our parent function. So this here is the parent function. I got my thing going here. No, it's not on. So our parent function, let's go ahead and write that next to this one. Write parent function on your paper there. That this is the parent function. Now remember, the parent function is the most basic function. It's basically like the original function. This is the original quadratic, x squared. And so as we start to think about how would we graph this, we need to know what is the vertex always first. Vertex is our starting point on this one. Now most parent functions, the vertex or the starting point usually is 0, 0. That's what it is here. It's the same thing on the linears. Your y-intercept is just 0. That's their starting point. You're on the absolute values, it also has a vertex, and that's 0, 0 for the parent function. So we can graph that point right away here. We can graph 0, 0. So we can put that point right there on our graph. And now the next points. So now typically we could, do a little table of values, right? We could do that. Anytime you want to, you could do a table of values for any graphing situation. We can always have that. If you're comfortable with this and you like that, that could be always something you go and do. So where would we want to pick now? We obviously wouldn't pick 0 because we already got that point. We would need to pick like 1, maybe 2 as well. We could pick those numbers for the x as inputs. We can put those in here, right? And say 1 squared is still 1. So we're getting 1, 1. And 2, if I plug 2 in, 2 squared is 4. So I'm getting 2, 4. There's points that I know are on my graph, and I can plot those. So we could do that. But there's also a pattern to this parent function. It's kind of similar to the pattern for the linear, where you have a slope, right? We know just rise over run. And we kind of go to that most of the time. Sometimes we don't do the table of values. Sometimes we just look at our starting point, and then we use our slope to get the next point. And then we draw our line. We can kind of do that here too on the quadratics. We can start with our starting point, this vertex, and then get the next few points. We need more than just 1 point to draw a U. Okay, we need about 5 points typically. A V shape, you can just have 3. But a U shape, you really need about 5 of the points. You need your vertex and then about 4 more up higher or up lower, depending on if it's going to open up or down. So here's how that pattern can go. If you go 1 this way, our x is now getting squared. See, when it was linear, it was just, by itself. You weren't squaring anything, but now we're going to square all the x's. So if we go 1 this way, from our vertex, 1 squared is 1. That tells me to go up 1. That is the same thing I have right here, 1, 1. If I go 2 this direction, I'm going to now square the 2, which is 2 squared, that's 4, telling me to go up 4. That's the parent function pattern. This is our pattern here. Whatever we do on this side, though, axis of symmetry is right through our y-axis here. We can do the same thing going up the other way. So if I go left 1, I'm also going to go up 1. I can go left 2 and go up 4, just like it did on the right side. I'm going to do the same thing on the left side. That's the points I need to be able to draw the U shape. See, if I only just get 3 points, like right here, I'll be tempted to draw a V. And I don't want to draw a V. I want to draw a U shape like it's supposed to be. So go ahead and try to connect your points together in a U-shaped fashion here. So kind of something like this. It's going up. It's always harder to do on this thing. There you go. Put arrows on the ends. Try to go up here as well. And arrows on the ends. So you can probably make yours a little bit better than mine. All right, let's go ahead and label a couple things on this parent function. We can label the vertex for 1. So our vertex is right here. That's our vertex point. Let's go ahead and label that one. That's the starting point all the time. We have an axis of symmetry. I'm going to put it as kind of a dashed line here. You can do a dashed line going down here. That's the axis of symmetry. Now, you might know that's the axis of symmetry, but how do you describe it? You know, it might ask you the question, what is the axis of symmetry? And what they're looking for is like a little equation. That equation is always x equals a number. It's x equals because it's a vertical line. It's x equals 0 on this one because it's just going through 0. It's going right through the origin. X equals 0 is how you would describe the axis of symmetry. Sometimes they ask that question. We can also talk about, like we saw before, this is decreasing here. So we're decreasing on this side from left to right. But as soon as we get to the vertex, we're going to then turn the corner and we're now going to go up and we're going to be increasing. So that's another thing you can see there from that. Decreasing on this side as you go from left to right across the graph. You're coming down, then you're going back up the U. Okay? All right, let's move on to our next one below. So that one is now going to add in a little bit. So now we're going to get off the parent function, but we're always going to compare it back to our original of the parent function. So now what are they doing? They're going to put a number in front of the x squared. And that number could be positive or negative. If it's positive, you know you're still going to open up with your graph. But if it's negative, it's going to open down with the graph. So as we look at this next one here, we have positive 2. So it's going to open up. So again, first question is always, what is the vertex? We want to know what is our starting point. That's always the first thing you got to find, is what's the vertex on this one. And on this one, there is no h or k. The h is usually inside of something. There is nothing inside here. It's just 2x squared. There is no k either. H and k are the vertex numbers, and if there is nothing there, it's still 0, 0. So our vertex is still the same as the parent function. It's still 0, 0. There's nothing that's changing the vertex. You're not moving it left or right. You're not moving it up or down. You're just going to be doing this 2 here. 2 is multiplying. That's an A number. Okay, A number is going to stretch or shrink your graph. It's going to make it wider or narrower. That's what this is going to do. So we know we're going to put a point right here at the origin. Let's go ahead and do that. Starting point. There's our starting point at the origin. We could do a table of values if we wanted, right? Anytime we want to do that, we can do that. So we could do that. We could say, I want to plug in 1 and 2 again. We could do that again. I could plug in 1 and 2 from here. If you plug in 1, 1 squared is 1, then you got to multiply it by 2. Well, that's going to be 2, isn't it? If I plug in 2, 2 squared is 4, and then times it by 2, 4 times 2 is 8. So there's a couple points that you can plot on this graph. But let's look and see how the pattern would work. So just the pattern, if I see, okay, here's my starting point. If I go 1 to the right or left, it doesn't matter which direction. If I just go 1 from that starting point, I got to square that number that I'm going. I'm going 1, so I'm going to square 1. But then I have to multiply by that A number. A number is 2. Still going to give me 1 times 2, so it tells me that same number. I didn't have to do the t-chart to know I'm going to put a point right there at 1, 2. The pattern tells me that as well. What about if I go 2 this way? Well, that means I'm going to square the 2, and then multiply by 2. So 2 squared is 4, and then times by 2 again, that's going to take me to 8. Now 6 is here, 8 would probably be up here a bit, so just put a point kind of up here a little ways. That is these 2 points. So we found those same 2 points with the pattern as we thought about the pattern. But whatever you do on this side, remember we're doing the same thing on the other. So I can go, if I went right 1 and up 2, I'm going to go left 1 and also up 2. If I went right 2 up 8, I'm going to go left 2 from the vertex and up 8 right here. There's another point right up there. And we can draw our graph now. So draw the U shape between these points. So I usually kind of start down low and make my curve this way and that way. Try to make a curve here, make a U here between these, and then you can just keep going up. Try to hit these points here. That's a point up there. And try to connect in that point. There you go, I got that one. So something like that. That's what our U shape should look like. Now we do want to talk about how is that different from the parent function, the original. Well, there's only one difference. This 2 makes it a little different. So notice that it did a stretch. Yes, exactly. It stretched higher. It got thinner and got narrower. So when you see this number is more than 1, it's always going to stretch. So what we could say here is it's going to have a vertical. We need to use the word vertical and the word stretch. So vertical stretch, and we're going to say by what number? Well, by 2. So why vertical and not horizontal? Because it's either vertical or horizontal. It's one of those 2 words. It's vertical because it's on the outside. It's in front of the x squared. If it was horizontal, it would be in a parenthesis inside with x. So it'll be very clear when it's horizontal. It'll show you a parenthesis and it'll be inside of a parenthesis. Or like absolute value, it'll be inside the absolute value sum is. That's when you know it's horizontal. But if it's ever on the outside, it's just going to be vertical. And majority of the time, you'll probably see vertical. Now, there's one other thing we didn't talk about in the parent graph, but I'll talk about it here. What about domain and range? Remember those guys? Domain and range. What about those? Because we still need to talk about those too. The domain for this, domain just means where is the graph on the x-axis. And on this one, you can see, and actually it's the same as the parent function. So it's going to be the same as if I was talking about the parent function. It's everywhere to the right, it's everywhere to the left. So at 1, it's here. At 2, it's up there. At 3, it's going to be even higher. At 4, it's even higher. Right? It's going to be everywhere to the right. The graph is everywhere to the left. Even though we don't see it because our window is kind of small right here, you know, eventually infinity is going to show us it's going to keep going left and right everywhere. So how do we describe that? We can use all real numbers is one way, or yes, you can use the infinity. You could say negative infinity to positive infinity is another way. You can also say it. But most of the time, you might want to just use all real numbers because that's very common as you'll see it through. But then you got the range, and the range is just where is the graph on the y-axis. Well, it's not everywhere. It's not down here, as you can see. It's only up here. It's only above 0, above that origin. So we're going to start by using the y letter. So it's always going to have a y letter, and we can use an inequality to describe this. Would this be greater or less going up? Yes. Well, up would be greater, right? Yeah, greater or equal to. You want to use that inequality symbol, greater than or equal to, and the number you're going to use is where it's greater than or equal to from. It's from 0. So it's right there from 0. It should be the same as your y coordinate on the vertex. Okay? That's the same exact thing as the parent function. So the parent function has this same domain, same range. In fact, all of the graphs we are doing is going to have the same domain. Every graph will have the same domain. So you shouldn't have to worry about the domain ever on these U-shaped quadratic graphs. It's going to be all real numbers every time. It will never change. The only time it would ever change is if you put your U-shape on its side and it was more like a C. You know, if the graph was more shaped like that, well, then it would change. But we're not going to do those ones. There are times we would, but we're actually going to skip that section. So you don't have to worry about the domain ever changing. It's going to always just be all real numbers. All right, let's try the next one, which is now going to add in a number back here. So you're going to have your ax squared, but now we're saying plus some number. And that number, they're saying C here, but I like to think of it really as K, because that's where we really kind of talk about it more in terms of K. C is usually talked about it in terms of the standard form. K would be in vertex form. I really kind of want to just focus on vertex form today and not think about standard form that much. So this number is going to move it up or down. It's going to move your graph, as you can see here, it's going to move it up or down from the 0, from that origin. So as we do this one, here's our graph, 4x squared plus 1. So we still have an A number 4, but now we have this new number here with plus 1. That's going to change the vertex point a little bit. So again, starting point is always your first thing to find, which is the vertex. That's the starting point. So there is no H number. So H is still 0. That number is still 0, but now we have a K number here. This is our K number. You might want to put K on top of that one so you realize that's the K number. That is 1. Your vertex is 0, 1 this time. So where is that? Well, it's just going to be 1 above the 0, right? 1 above the origin. Just put a point. There's our starting point. Now we could do a table of values, but let's just go to our pattern, right? If I just went from the pattern, I'm not going to go from 0 because that's not where my vertex is. I'm going to go where the vertex is from, right? My starting point. If I go 1 to the right of my starting point, that puts me here. I'm not going to put a point there though. I now need to do like a slope. Remember how slope goes rise over run? We're going to do pretty much the same thing, but I like to run first, then rise. Okay, so that's kind of how we're going to do it, just a little bit opposite. Run 1, but then how much do we rise? Well, that's where we got to square the 1, which is still 1, right? 1 squared is 1. And then we got to multiply by the number here, 4. So what is 1 times 4? That's going to still be 4. So you're going to tell us it's going to rise 4. So I ran 1, I'm going to rise 4 from that. Puts me right here at 5. So there's a point at 1, 5. If we did this over here, table of values, and I chose 1 to plug in, I'm going to get 5, as you could see, right? If I said 1 squared, that's 1, times 4 is 4, add 1, that would be 5. So you could still get the same thing doing the table of values. But just the pattern does help. I like doing it because it kind of builds my parabola just going up. So I know whatever I do this way, if I'm going to go 1 and up 4, I'm going to go 1 this way and also up 4, evenly, symmetrically on the other side. Now let's try if I go 2. I could put 2 here. I could say I'm going to try 2. If I go 2 from my vertex point, which is still going to be 2 on the x, sometimes it won't always match up over here, so that's why don't worry about that. If I just go 2 from my vertex, you're going to run 2. How much do we rise? Well, that's going to be a lot, isn't it? It's going to be, what? We got to square the 2 first, because we're always going to square the number. 4. 4 times 4. 16. We got to rise 16. Well, I'm not even going to try to put that point, right? That's just too high up. So I'm just going to stop with these 3, but I just don't want to draw a V shape. I just want to draw a U shape here. So it's okay sometimes to only have these 3 points, just as long as you make it look like a U and not a V. So I'm going to definitely kind of make my curve down there by the vertex and do it something like that. Okay, so just make a U shape out of it, not a V shape. Now let's talk about how does that compare to the original. Well, there's 2 things we could say. It has this 4 up in front, so that was a vertical. Is it stretch or shrink? It's stretching because it's bigger, right? It definitely got thinner. It even got narrower than the last one we did. So it's a vertical stretch. And by how much? By the number 4. So it's by 4. That's one thing we could say. We can also talk about how it moved up 1. That's called a translation. Remember that word? Translation is when you got to talk about when it's going to move up, down, left, or right. Move around, you're going to translate. So translation, and we got to talk about the direction and by how much. We could say how much right away by saying 1. It's going to translate 1 unit up. Exactly. There it is. So that's how we want to talk about our comparison to the original parent function. And if we said, okay, domain and range. So our domain on this one is going to always be what? All real numbers. Remember, that doesn't change. Every single time. You just know you're going to default to that answer. The range on this one is going to end up being y. And let's see, it's going to still be greater than or equal to, right? Because it's going up. So we'll still use that inequality. But from where? From 1 this time, not 0. Because we went up 1, so it's from 1. There's our range. All right, let's take a look at now. So now we talked about the K. We're going to talk about the H next. So I'm going to skip over this one. I put this one in here before, but I don't want to talk about standard form yet. This is the standard form. That's why they use the C sometimes. But we'll come back to that. We were going to get to that. We're going to get to all that stuff too. But let's get to this one now. So still looking at vertex form, we see an H. The H is going to move it left or right. Now that's what that does. It moves the vertex left and right. When you see a number, see, now we can see the parenthesis. We see the parenthesis, we see the number inside. That tells us how much to move left or right. All right, so here's our problem. 1/2 times the parenthesis x minus 4 squared. We got to start with what is the vertex. That's always your very beginning. Always got to know where do you begin. You start with the vertex. Vertex here, there is an H number. H is right there. That's your H. So is the H -4 or +4? This is where it gets a little confusing. It's going to be +4. Okay? So remember, when your H number is always like the opposite of what it appears to be. It appears like it's -4 in here, but when you actually got to pull it out to put it in the vertex, it really is just going to be 4. Because up here you can see it says x minus the H. The minus sign is like in the formula. It's already there. So if this said x plus 4, then our number would come out as -4. So it's kind of always the opposite of what you think it might be. Now there is no k on this one. K would be back here, but there is nothing there, so it's still going to be 0. So there's our vertex. Let's go ahead and plot that one. That's right here on the x-axis. 4, 0 is right there. Now, if we wanted to, we could, do a table of values. If I wanted to pick some numbers for the table of values, you need to be smart about the numbers you pick sometimes. Not just all numbers are great numbers to pick to plug in. If I plugged in, let's just say 1, if I picked 1, if I put 1 over here, that's not a great number to pick. Because notice, what am I going to have to multiply by eventually? This fraction of 1/2, right? That means I got to cut a number in half. Can you cut an odd number in half evenly? No, it's going to still give you a fraction. We don't want to end up with a fraction. So we want to choose numbers that will give us an even number that we can cut in half so we get a nice, easy number to plot on our coordinate plane. Okay, so that's what I would be doing. I would be maybe choosing 2, maybe even 0, or maybe 6. Any of those numbers would work as far as giving me easier numbers. So be smart about the numbers you choose. But before I do that, let's go ahead and just look at the pattern. How would the pattern work on this one? So here's my starting point. If I wanted to run 1, right, just run 1 from that starting point, how much do I go up? Well, remember to square the number. Square 1, we still got 1. 1 times what? What's our number to multiply? Our A number? The half. What's 1 times a half? It's a half, right? So it tells me if I'm going to run 1, I'm going to go up a half. That's how far I go up. I can put a point right there. Go ahead and put a point there. At 5, you're going to go up a half. So that means on the other side, if I run 1 this way, I'm also going to go up a half. So there's that point too. What about if we run 2? So if I run 2, we got to first start to square the 2, right? Square that 2 and get 4. What do we need to multiply 4 by? The half that's in front, right? What's half of 4? 2. So that tells me to go up 2, rise 2, run 2, and rise 2. There's another point. I can go the other way, run 2 this way, and rise 2. There's my symmetrical points on this parabola. Now let's take a look. If I chose 2 right here, I'm going to get 2, right? If I plug in 2 here, I'm going to get negative 2, and negative 2 squared is 4, and half of 4 is still 2. Or if I plugged in 0 here, if I did that one, I would get negative 4 inside here, and negative 4 squared is 16. Half of 16, multiplied by a half of 16 is 8. So I would get 8 there. So I'm getting these same points. As you can see, I got the 2 right there even from my pattern. Eventually, as we would keep going up, our 0, 8 would be way up here. We don't really need to draw that one. You can if you want to. But this is enough to be able to graph this. This is all you need. So go ahead and just draw your U shape from here. So this is a little bit of a wider U. So it's a little wider here, as you see from the last ones we did. So it's doing that thing. Put arrows always on the ends. It's coming up this way. So as we start to talk about how to compare, how does this compare to the original, this original one here?
It's a shrink.
It's not a stretch, it's a shrink, right? So it's still vertical, right? Because the 1/2's outside. See, if it was going to be horizontal, we would be seeing a number inside the parenthesis. And there isn't a number inside the parenthesis in front of x. The number is outside, so it's vertical still. And it's a shrink this time because that number is less than 1. It made our graph wider than the parent function, and it was a shrink by how much? What was the number used? Let's use the half, so shrink by a half. We also can talk about there's a translation on this one. It moved from 0, 0, so we could talk about translation. And we always want to talk about direction and how much. So how much is easy, right? How much did this move? It moved 4. So it went 4 which way? 4 units right. And so that's how we can talk about that. So these aren't meant to be difficult. Just got to know how to work with them and how to play with them, you know. And as long as you understand the rules, it's easy. We could talk about the domain and range again. Is the domain going to be different than anything else we've seen?
No.
It's still the same. Yep. So we could just still say all real numbers for that. That's always the same. Range, though, does change every now and then. Is it going to change this time? It's still going to always say y, though. Is it going to be a still greater than, or is it less than this time? Still greater than, because it's going up. So still greater than. And from where? Is it from 4 or is it from 0? Still from 0. It's this number here, right? It's always y. Is that's the y number. So it's still 0. It didn't go up or down at all. Still stayed on the x-axis. Anywhere on the x-axis is still going to be 0 for the range. Let's look at our last one now. It puts it all together. Does it all in this one. It's going to give us an A, an H, and a K on this last one. So that's what this is. It shows you your H and your K. We have our A number. So this is the form of it. Remember the absolute value one was exactly the same, except instead of the parentheses that's squared, it just had absolute value symbols, but it was the same form. Vertex form for both of these is the same form, just absolute value symbols for absolute value functions and parentheses squared for the quadratic functions. Your H comma K is your vertex. So let's look and see what would the vertex be on this problem here. We got H is here, right? We know that's our H. K is over here. So we got to think about what the vertex is. Write it down yourself. So write the vertex down, identify it yourself. Fill that in. What is the H and the K? So H, what's H going to be? What's the X number here? So -2, right? Because it's always opposite. That's the twist, right? That's the little confusing part. Well, it looks like it's +2, but when you pull it out for the vertex, it's really a -2 there. What's the y coordinate? It's just 3. It is what it is. So we can plot that point. So we're going to go -2 and up 3 right there at that point. So now we could go to our table of values, but I just want to go to that pattern again. So we start from the vertex. That's our starting point. We're just going to go 1 unit from there, run 1. Now, is this going to tell us to go up or down this time?
Down.
Yeah, the negative is going to tell us to go down this time. And so we're going to still multiply by the number, though, -2. So by go 1, you guys still got to square the 1. That's what you got to do first. Square it, because we're talking about squared functions. You're squaring the x's. Squaring these run numbers that you have. So you run 1, square that, you still get 1. 1 times -2 is -2. So it tells us to go down 2. We're going to put a point right there at -1, +1. So if I plug that in, let's just check that, just so we can see how that does work. If I plugged in -1 for x, do I get +1 for y? So if I put -1 here, that's now going to be taking away from 2. It's just a 1 here. 1 squared is 1, times -2 is -2, and -2 plus 3 is +1. So I'm checking that in my head, but I'm verifying that that's right. That worked, okay? And if I go 1 this way and down 2, I'm going to go 1 the other way, go down 2 as well because of axis of symmetry. Let's run 2. Run 2 takes me maybe over here to the y-axis. So 2 squared is 4. And then what's 4 times this a number right there? 4 times -2 is -8. So it tells me to go run 2 and then go down how many? 8. So it takes me all the way down to -5 is going down 8. All the way to there. So 0, -5 is a point. So if I run 2 the other way, I can also go down 8, which is going to be -4, -5 as an ordered pair point. So if I checked any of those, I'm going to get those numbers for the y's. And now we have enough points to draw our parabola. And it's opening down here, so it's more like an arch. Let's see, just do your best at making that a U, upside down U shape. Mine's really hard to do on this thing. Hard to draw these curves. And there we go. Okay, not too bad. Now, when we talk about, when we actually get into the Chapter 2, Chapter 3, we're going to talk about real-life problems. When we talk about real-life problems and we're dealing with a parabola kind of problem, and they might talk about a parabolic shape, that's another way of saying parabola, they're always going to be, the real-life ones are most always going to be these kind that are opening down. Because real-life situations, open down. When you think about any sports I can think of really, deals with a parabola that's opening down. If you hit a baseball, typically it's going to go up in the air. If you shoot a basketball, you're shooting it up. If you hit a golf ball, it's going up. If you throw a football, it's going up. Everything is kind of doing this shape, right, as you toss it, as you throw it, as you hit it. And so we talk about real-life problems in sports. They often talk about these parabola shapes doing that kind of thing, but they're always going to have a negative in front of their equations. Not very often in sports you're going to see the ups, the U shapes, just because that doesn't usually happen. There are times when you will see U shapes, maybe in a roller coaster ride. You're going to have a U shape then, up and down. You'll have ups and downs and things. So you might have some U shapes there, but most of the time in our real life problems, when we get to those, it'll have a negative in front and it'll be more like this. Let's talk about how this is different, though. We have a few things to talk about. How is it different from our original? So let's talk about reflection. It opened down. That's a reflection. But we always want to talk about in a certain axis. Is this the y-axis or x-axis reflection? What's it reflecting over? Yeah, it's reflecting over the x-axis. That's a vertical reflection. When would it be a y-axis? Well, that's when the negative would be on the inside where x is. Okay, yeah, and it flips left, right, but you'll see you'd see a negative on the inside where x is. Right now, our negatives are out in front, it's outside, so it's going to be a vertical flip, flipping vertically like this. We can also talk about the different. Is it a stretch or a shrink on this one?
It's a shrink.
Oh, no, not a string. It's a stretch, right? Because it got narrower. You could see the 2 right here is more than 1. It's not a half. It's a 2. So it is a vertical. It's still vertical because it's on the outside. It is a vertical stretch, even though it's opening down. That doesn't have anything to do with shrinking, though. So it's a vertical stretch by the number 2. You might say factor of 2, but we can just say by 2. We can also talk about how it has a translation. It's actually got 2 translations, in fact. It's got one translation that's going to move it left, how many? 2 units. So we could say 2 units left. And it went up, how many? 3. So we can also say 3 units. This is my units here. Units up. So it really has those 2 translations. And as far as domain and range, we know the domain is going to be always the same. We know that's all real. But what about our range on this one? That one might have changed here. Still going to use the y. Is it greater than or less than on this one? This time it's less than, so that definitely changed. Less than or equal to from where? From 3, exactly. From that number 3 on the vertex. That's our range on this one. All right, so you want to go on to looking at the back now. You have 4 problems on the back. That's what you're going to complete before I check that or have you turn that in.